Okay. So, how y'all doing?
Great.
Y'all try that normal curve crap? I mean stuff.
I don't get it.
Okay. Yay, nay? What do you think?
It's hard.
What do you think? You want normal curve stuff? You want to that stuff? Okay. I figured that's what we would do. We would look over this normal curve stuff. Wednesday we'll have a test review, and then have our test next Monday. Then that Wednesday, next Wednesday, we'll talk about section 13.1 about the samples and stuff, and then the following Monday we'll talk about 13.2, which is misuse of statistics, and then we'll have a final review on that Wednesday.
Monday, that first Monday of the week.
Yeah, they
So the first?
they published the
Yeah, it's the third.
they published that thing, right? They sent y'all an email about it, or is it?
I didn't get an email, but somebody told me they put posted on the
I
website.
didn't
Okay.
check my emails.
Check. No, no, it's on the website. I don't want to say something because I don't want to be wrong, and then you can do it.
No, it's not.
I know, but that's well, it's not that I don't trust you. I don't trust anybody. So, yeah.
So,
Go to the website. Yeah, she's got it there. You went to the website.
My reading is your opinion.
Okay, so if you want a copy of it, you can go to the website. It's the very first thing.
technically, we only have like 2 weeks.
But it didn't have 110 on it.
I don't know.
Well, you just yeah, the 110 is not a common hour final. So like 120, 150, all the 155 take the same final.
Isn't
This
it?
one doesn't. This one is my final, so I can do that. So this we meet here what Monday, Wednesday at 9:30. So Monday 10:30 in this classroom.
Yes,
How do you figure out
I think I'm looking
Yeah, do you have a class after this one? 12:30.
at anybody else.
Oh, yeah, dude, 12:30.
Okay. Yeah, this one here says classes that meet Monday, Wednesday at 12:30.
Oh,
1:45. Then you're gonna take it at 1 o'clock. This day.
that's good. Anybody else?
I just it's you can download it off the website.
I'm just going to I'll just copy it.
Yeah. So I don't know if that made much sense. So I didn't bring a calendar or anything, but so today. So today we're going to do the normal curve. That's. And then this Wednesday, this week. First, you got. What is next? What is this Wednesday? Today's something. What is it? Today's 12th. And
Is it
then
still in this room? Like,
yeah, the files in this room. They should be in the room that they're marked. So we're going to do on Wednesday, the 14th. We're going to do a test review. And that test review will cover everything that up to normal curves from the last test to this one. So basically logic and normal curves will be a big chunk of it. Yeah, because we started talking about logic graphs. Okay, so we'll have the logic stuff, the truth tables, and then we'll have our stats stuff, which is from chapter 13. This is chapter 3 and chapter 13. And that includes, mean, median, mode, range, mid-range, standard deviation, and the normal curve. We'll talk about this on Wednesday a little bit, right at the end of the class list. And then the 19th, which would be the next month, a week from today, is test 4. Then the following Wednesday after that, what's the date on that Wednesday? 21st. We're going to talk about 13.1. I talk about 13.1 that day. The following Monday, what's that? 11:26. 13-2. And then the 28th, we'll have a final review. And it's scheduled for the 4th. Correct, Amy? Final? 3rd, Monday the 3rd. So when you write it out, it seems like a lot, but then when you start thinking about it, it's not much time. There's just the rest of November, and then very first Monday, December is the final. So we're sitting pretty good. Make sense? Bonus.
Listen, I can take the
Listen. Listen.
I'm nervous.
Okay, don't be nervous. Well, I tell you what to really focus on this test, you need to make sure we can do this logic stuff, like the logic table, the truth table. Okay. You need to make sure we can do those. And on the stat test, we need to make sure we can do these normal curves. So I think the mean, median, mode, range, that kind of stuff, I think everyone pretty good on it. So what we're going to focus on today, at least, is just this normal curve. And then when we come back for this test, the test review on Wednesday, we'll focus on the logic questions as well.
Right. So I asked somebody if they should do that. She's like, I've never seen this.
Yeah, a lot of it's hard to go and get help because of that.
And then I took it home and like twice.
We're gonna try to focus really on it, and that's what we're gonna try to do. So we're gonna try to knock out this normal curve stuff today, and then the logic stuff, and a few of the stats things on Wednesday. Okay. All right. So we're gonna look at the rest of this paper, I suppose, and then we'll check some questions out of the textbook, and you got to have one of these normal curve papers. So you got to have one of these papers, and if you don't have one right now, I've got one. Does anyone need one? Morgan, you need one? Probably this other worksheet too. Don't you? You got this one? The Z table. No. Anybody else need one? Everybody got one? Okay. So where did we wind up last time? Where would be a good place to start here? The word problems, number 16? Yeah. Okay, so number 16 is on this paper. I think I put this on Blackboard. I'm not for sure if I did or not. If not, I'll try to post it. Assume that the weights of quarters are normally distributed with a mean of 5.67 grams and a standard deviation of 0.070 grams. A vending machine will only accept coins weighing between 5.48 and 5.82. What percentage of legal quarters will be rejected? And I don't think vending machines work on weight. I think they work on size. I don't know. I'm not a vending machine repairman, so I don't really know. But the mint, the people that produce quarters, is they all can't be the same, exactly the same, right? Quarters, they can't all be the same, right? There has to be some variation between them. Does that make sense?
You have no weight,
In their appearance, in their weight, and in their size, I think. Well, size might not be so much, but it might be size too, because if they're stamping them out, that metal that they stamp them out on, it might have irregularities in them, so they might weigh different amounts. And I had a colleague at the high school that she took a bunch of pennies, and they weighed a whole bunch of pennies with a scientific scale, 3-beam balance, whatever, and they were way off. I mean, they were not, well, I said way off, like 0.48 and 0.82, or that's the way off part that I'm talking about. It's not a whole lot when you really think about it, but 5.48 and 5.82, that's a big difference between weights, and it actually came out to be that way in real life. If you actually wanted to go get a bunch of pennies and weigh them, I had this harebrained scheme because before 1988, pennies were made out of, they were 98% copper, and after 1988, they turned out being 3% copper. So if you could go to the bank and get some pre-1988 pennies, they're worth more than a penny just because of their copper value. So my harebrained scheme was to go to the bank and get $100 worth of pennies, which 100 times 100 would be 1 with 4 zeros, would be 10,000 pennies. And then melt them all down, and hopefully I get the scrap value for them. But you could use statistics in this, because what I would do is I'd go and get $1. I mean, I don't know. I'd go get $10 worth, which would be 3 zeros. That'd be 1,000 pennies. And I'd go through those 1,000 pennies and sort them out. I know it would take a while, but I'd sort them out and see how many pre-1988 pennies and newer pennies there were. And it's called the law of large numbers. If you take this, you find the probability of a 1988 coin in this 1,000 pennies. If you did it for the 100,000 pennies, it's going to pretty much stay the same consistency. So, but I got online. Other people have thought of this before. If you ever have a harebrained scheme, go online and look it up, because other people have done this, and they found that their statistics didn't match up. It wasn't going to be worth it, because not only do you have to get enough pennies to make it worth. See, the other past 1988, they're zinc pennies. The core of a penny is mostly zinc, which zinc has value too. But anyway, they didn't find that there was enough pre-88 pennies in their sample, basically. So anyways, that was my harebrained scheme, and it didn't really work very well. Hey, okay. So anyways, I'm going to draw, for these questions here, I'm going to draw out a normal curve, right? That's the first thing I want to try to do. Pencil here. And then the reason, what's the part in here that tells me that I can use the normal curve here? What's the part that tells me that? There's actually 2 words in here that tells me it says normally distributed. When it says normally distributed, we can use the normal curve. Okay, if it didn't say that, you're not supposed to be able to do it. So I can draw the normal curve, which is this bell-shaped curve. So I draw that in. And then what goes in the middle here? The mean. The mean always goes in the middle, the average. So I look through here and I find what the mean was. The mean of 5.67. That's the average weight. I probably should have drew this bigger. The standard deviation is 0.07. 0.07. So get my calculator out. I'll use my not so fancy calculator. And I take 5.67 and I add the standard deviation, 5.74. So here my first standard deviation here is 5.74. Then I add another 0.07. I get 5.81. And then I add another, I get 5.88. And then I'm going to do the same thing but in reverse to get the back numbers here. So I'm going to take 5.67 minus 0.07, 5.6, and then take away another 0.07, 5.3, 5.53, take away another 5. Take away another 0.7. How do I get to delete that? 5.46. And so I get my little standard deviations. So if I was to pick a quarter, I have a 50% chance it's either above 5.67 or below 5.67 because it's right in the middle. This normal curve, 50% is above it, 50% is below it. Does that make sense about this normal? What this normal curve does? It basically tells you the distribution of all these quarters. So half of them are above 5.67 grams, and half of them are below 5.67. Now, the other percentages are a little bit different from each standard deviation, and that's why we use the table to get those percentages. So what numbers do they ask us for?
5.4,
5.48 would be right here, right? And 5.82 is up here. So I want to figure out what percent of the area underneath this curve, what percent am I shading in out of 100%? That's what I want to figure out. Does that make sense? That's what I'm looking for. A second ago I said, well, half at the mean is half, right? So 50% is above and 50% is below. But this time it's a pretty big. I shaded in a pretty big chunk of that curve, right? That's a big. It's probably over 90%. But I need to figure out what this last little piece is and this piece over here. I don't want those pieces. So here's what I would suggest we do: is the table, this table over here, the normal curve table. They call it a Z table. Because what it will do is it will tell you what these areas are, these shaded regions, to the left of your standard deviation. But the first thing you have to do is convert it to a Z-score. That's the first thing you got to do. To use this table, you got to have it as a Z-score. That's why they say Z. That's a fancy way of saying how many standard deviations we are away. So, for instance, if this question had said 5.74, how many standard deviations is 5.74 away from the mean? 1. And the 5.81? 2. So if the question had said 5.74, which is 1, then I just come over here to 1 and I use that table value of 1. Or if the question had said 5.81, that's 2 standard deviations away. So I would have used the 2 on this table. The problem is we don't have exact standard deviations, do we? No. So we have to compute something called a Z-score. Basically, we're saying how far away is this number in standard deviations. So I know it's more than 2, right? No, it's more than 2. So remember the other day where I wrote it on the board of the formula for finding these things? How should we find this?
Take your, excuse me, like your starting number that you're looking for.
Okay, so that's starting number.
And you subtract the mean.
We subtract the mean.
Then you take the answer from that and divide it by the deviation.
You divide it by the deviation. So that's what we did last time. It's one way to look at it with words, but basically, if I want to find the Z-score for 5.82, how would I fill things in over here for this 5.82? I want to find the Z-score right here. So what would we do? Okay, so slow down a second. We're going to take the same way here, right? 5.82, that's that starting number. Subtract away the mean, which is 5.67. Now, I would suggest you just do that step right there. Figure out what that number is. So, clear this off here. 5.82 minus 5.67. I get 0.15. Y'all get 0.15? When you did that? Okay. So 0.15. Now we're going to take that number and we're going to divide it by, what's the number we're going to divide it by here? 0.07. So I'm going to divide that by 0.07. So I get 2.14285, blah, 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 blah. Right. So what do you think we should round to? It doesn't say to. What do you think we should round? 2.14? How come? You're right, I agree with you. Okay, but why? That's correct to round, but why stop there? Why not me go over here and round this? The chart we use only uses 2 decimals, so there's no point in rounding it to anywhere else. So 2.14 is what that z-score is. So that z-score there is 2.14. So you guys try to find the z-score for 5.48, because we're going to need it too. So try to find the z-score for 5.48. From the question, it says in the question, the standard deviation. Assume that the weights of quarters are normally distributed with a mean of 5.67, so that's the average, the mean, and a standard deviation of 0.07. Yeah. You don't have one, Kia? I thought you had one. I'm sorry. Anybody else need one? Which one of these two? Oh, I'm sorry. I thought you had one. And we divide that by 0.07. So negative 2.771. Now remember, I'm doing the first part, the top of the fraction first, and hit enter, and then divided by 0.07. It can throw, if you don't use the right parentheses, it throws things off. Okay, so if you want to do that all at once, you have to put the parentheses on the top of your fraction. So the z-score here is negative 2.71. Is the negative important? Yeah, because if you flip your paper over, then one side's got all the positive z-scores, and the other side has all the negative z-scores. Okay, so here's what we're going to do. We've got to figure out what that area is right there. So my table, the way this table works, is you tell it a z-score, the ones we just calculated, the negative 2.71 and 2.14. You tell it a z-score, it will tell you the area to the left, all the way to the left, all this shaded region here. Kia, I just gave you this, right? You just had this one. This right here is supposed to be nice and shaded, so it didn't come off very well on the copy machine. I'm not a very good colorer. Okay, that's what it's supposed to look like. So let's put in the positive 2.14. So I'll go to 2.1, 2.1 row. Okay, go to the 2.1 row. And now what was the second decimal there? 4. So the first one is a 0, the second one's a 1, a 2, a 3, and a 4. 0.9838. Okay, so what that means is that from this little guy to the left is 0.9838, which is 98.38%. From there to the left, all the way over to infinity. Did y'all catch how I converted that to a decimal to a fraction, a percentage? So I just converted it on there. But now, do we want from here all the way over? You don't want all that, right? You got this little white part here you don't want. So I'll tell you what we're going to do. We'll find the z-score for this guy, and it'll tell us that white part from here to the left. So I got to use the negative side because it's a negative z-score. It's 2.7, right? 2.7, and then what was the second decimal? 1. So this guy right here. What's going on back here? Okay, yeah, that's because they're all like with red vests on. Someone has very large group of children. Dressed them all the same today. Okay, that was weird. Small army of children out there in uniform. No. Okay, so from here over is 0.0034. But I'm going to convert that to a percentage. 0.34%. So that white part here is 0.34, which we don't want. And we want the shaded part. So what if we just subtract these two numbers then? I'll give it to you. Now I have done this in super slow motion because I know you're thinking, man, this takes forever.
I can do it if I can remember all the steps.
Well, basically, just find your z-scores. All you gotta do is find the z-scores. I mean, what you want to do in math is try to take out. Like, have you ever took? Okay, go ahead. You got a question?
Why is it 0.34 not 10?
The z-score was 0.0034, and when I convert it to a percentage, yeah, anything way out here is going to be really small. Okay, anything out there is going to be really small. Now, have you ever took a public speaking class? Did you ever take communications and public speaking? Oh, that's ridiculous. You took it online. Okay. So when I took basic public speaking in a classroom and I taught in front of people, they told me that you should have note cards, but the note cards shouldn't say everything that you want to say on them. You should have the main points, and then you fill in the main points by speaking, right? You just kind of fill it in. So that's kind of the same way here. Is you don't want to fill up your brain with a whole bunch of little steps besides the main points. And the main point here is draw a picture, okay? And I know that to draw a picture, I just add, subtract the standard deviations. So okay, that's kind of the thing there that I knew. Then I find the z-scores for my numbers out of the problem. And you got to know how to, the little steps you got to know. So the z-scores you subtract and divide by the standard deviation. And then you're going to look at your table and figure out you knew to subtract because you didn't want it. So it's three main steps, but then there's little corollaries off of those three main steps, and that's all the stuff that's hard. That's the thing that you want to be able to do, is make sure you understand the main steps first, and then make sure you understand the little corollaries underneath those. So, and like I said, I did it in very slow motion to try to explain it all at once. Let's try it. What does it say? Yeah, let's make sure we answer the question, because once you do that, it says here, what percentage of legal courts will be rejected? We didn't find what's rejected. We found what was accepted. You just got to make sure you read the directions very carefully. What percentage of legal courts will be rejected? So, out of 100%, subtract away the 98.04. What do you get? 2.9 or 1.96? 1.96. And there's different ways to do this problem. I mean, you could have done it shaded the outsides and done it that way. I know the graphing calculators, you just type in the z-scores and it will tell you the percentage. I know it can do that. I don't know about these Casios. I know you and Morgan have the same thing. I'm not for sure where it is, but the tables is just as good.
That's what I say. It seems like it's actually faster just to go use the table and just do basic.
It is. If you take a stats class, though, that's the way to do it, because you want to have a whole bunch of weird intervals. It's a little bit easier to do it that way, but some people like using the calculator, and some people I like the table. So okay, so do we answer the question now? 1.96, because I subtracted it from 100 because it wants 98%. 98.38 from 3.34, and then I subtracted that from 100 because it wants the rejected quarters, not the accepted quarters. I shaded in that shaded region as the accepted quarters. So that means if you have, and this is pretty horrible. That means if you had 100 quarters, 2% of them wouldn't work. You're going to lose 50 cents. That's
What's
two.
that normal for a bad edition?
Yeah, sure. I chucked $2 into a vending machine the other day for a water, and they didn't have any water, so I hit the return money and just spit $1 back out. I'm like, well, no wonder they don't put waters in them. If they're going to make $1 per return. I hit it wasn't a look-in machine. It wasn't this one. It was just a regular vending machine at a hotel. And
The hospital, that's all they sell is like pop.
no water?
Yeah, like every time when I was in the hospital, my contractions, they told me not to drink any pop, just have all water.
Yeah.
I sent my mom to go get me some water. There's some out of water. She's like, oh, that's like cocaine. I'm like, seriously? It's ridiculous. You're the hospital.
Yeah. I always when I would go to the hospital, go into little nursing stations and
I have my
raid the refrigerator. They usually have like a little. Don't they usually have like a little kitchenette kind of thing? You can go in there and get ice and water and Shasta pop and
They bring you ice and water in a little container.
Yeah.
And if you want a soda, it's like a
little bitty can of Shasta. Yeah.
ridiculous.
It's like, yeah, I know.
Shasta must be good stuff. That's what you breathe the blood for.
Yeah. Can't find it anywhere else besides the hospital. I suppose, but I don't know. I can't find it. Let's see if this is a little bit better. Income to trainees, a local mill, are normally distributed. That means we can use the curve. Okay, that means we can use the curve. So I'm going to come down here and do number 17. Okay, the middle goes the mean. So where's the mean at here? $1,100. The standard deviation is 150. So I'm going to add 150, and I'm going to subtract 150. 3 times. Usually anything past 3 standard deviations is way too small. So you just need 3. So 1,100 plus 150. What is 1,100 plus 150? Okay, and the next one? And the next one. And then we're going to go down by $50.
950.
Okay.
650.
So you're adding 150?
Yep. Yeah. So we're just adding 150 going this way, and then subtracting 150 this way. And all these numbers come from the actual questions. Okay, this is a good part of the battle right here. So now you want to know what percent of trainees earn less than $900. It's right here. That's where 900 is, right? I wish it was 950 because that would be 1 on my table. Or if it was 800, it'd be negative 2 on my table. 950 is negative 1 on the table. Why is 950 negative 1 on that table? It's on the left side because it's negative. But isn't that 1 standard deviation away? That's $150 away, right? That's why it's 1 on the table. 800 is 2 standard deviations away. So it's negative 2. And 650 is 3 standard deviations away. It's negative 3 on my table. But the problem is 900 falls in between negative 2 and negative 1. So I know my answer is between those 2 numbers. Let's find a little z-score for that, dude. So, if I recall correctly, you take your number that's given, the one you're looking for.
So your starting number is 100.
Yep. So $900 is what you're starting with. Then you subtract away the mean from that. So that was $1,100. So that winds up being negative $200. And that's fine because you want the negative because this is on the negative side, right? Yeah. So negative 1.33. We divide it out. Okay, now, if I do that, if I look on my table, it's going to tell me, I don't know what the question is going to ask, but it's going to tell me this part right here. That's how the table works. It works from that number, that z-score, to the left. Is that what we want from this question? It says, what percentage of trainees earn less than $900 a month? So yeah, it actually does tell us. This, what we get on the table will be our answer. We're doing it from the 900 because we're going to use the z-score of 1.33. So I'll come over here in my tables. Negative 1.3 row. It's the row 1.3. Negative 1.3. 0, 1, 2, 3. This guy right here. 0.0918. 0.091. I think I said that wrong, didn't I? Okay. So we want a percentage, though, so we're going to change it to a percentage. 9.18%. That's the percent that earn less than $900 a month. Do what? They're all easy, aren't they? So much fun. Let's see if number 18 is hard as heck. I appreciated you kind of toned it down there. That's good. We were recording all. Okay. Average size of fish in a lake is 11 point. Oh, does it say normally distributed in here? It doesn't. So we're going to assume it is normally distributed, since the rest of them are normally distributed. It's supposed to say that, right? It doesn't say it, but it's supposed to. Do what now? What's that? Well, no, I think fish could. Well, if you think about a population, the size of a population, most of them should be all bunched around this average, and then, there's not going to be a whole. I don't know. Would there be more baby fish in a lake than?
Well, how many fish? How many eggs do you put?
Oh, thousands.
Okay, so there will be more.
You have to remember natural selection.
Lots of stuff eat little baby fish too. I would say certain times of the year there's more baby fish in the lake than there are average fish. Average. But through a good portion of the lake, good portion of the time, it would be normally distributed because most of the fish would be this average size, and you got fewer and fewer bigger ones because they get selected by fishermen. And then you have fewer and fewer. But if you think about it, there's a size limit here on Lake Cumberland of 15 inches. Yeah, so to keep them. Okay, it's not like you can say, oh, there's one, and then you try to catch it. You catch it, and then if it's not 15 inches, you throw it back. So really, that means that there's probably a whole lot more fish that are smaller than there are those bigger ones. So it might not be. Anyways, we're going to draw a normal curve. We're getting into more of a statistics class than just plain old 110. So we're going to put what's the number we're going to put in the middle? 11.4. Now I'm going to go up by the standard deviation. And I go down by the standard deviation. So what is the standard deviation here?
4. If you add it going up, it'd be 14.6.
So add 3.2, you get 14.6.
Add again, you get 17.8.
17.8.
Add again, you get
21. Okay. Then you're going to go down now, right? To the left, you're going to go down the 3.2 inches.
8.2.
8.2.
5.
5.
1.8.
And what?
1.8.
1.8. Little babies.
And I've actually caught a fish that small.
Oh, yeah. Yeah.
It's on slow.
Yeah, I caught a little salamander one time on a crankbait. It was really big. I don't know how. Caught salamander, huh? I just thought it was a leaf. That leaf's moving. What the crap's that all about? Okay, so now it asks for percent of fish longer than 17. So longer, 17 would be out here, right? Oh, no, it's right here. So there's 17 inches. But longer is going this way. Well, we have an issue here, right? Because our table doesn't work that way. Our table moves to the left. It gives us to the left percentage. So what are we going to do at the end with our answer?
You're gonna take that.
We're going to subtract from 100, right? We're going to have to do some subtraction. So you go to your table. Oh wait, we can't go to the table yet, can we? Yeah. Z-score? Yeah. I was going to go to the table, and that wasn't going to work because you got to have z-scores, right? You got to have z-scores. So 17 minus 11.4. You take your number minus the mean. Here's another trick that I've come up with here, Taylor, is every time I do this, I don't just write the numbers down, because if I go back to look at this, it's not going to make much sense. So I'm going to write down what these numbers are as I go through, and every time I write it, it sticks a little bit further into my brain. It's like a little splinter that you stick in your brain that just won't come out. Okay, so what is that number when you read it? 5.6. Now we're going to divide that by the standard deviation, which was 3.2. Now below this, I'm going to put standard deviation or standard dev, STDDV. So what is that number?
1.7.
1.75. Okay. Now we can jump over here, and it's a positive. So you go to the positive side. 1.7 is the row. 0.7 is the row. And you just, what was the second decimal? 5. 0, 1, 2, 3, 4, 5. 9599. Okay. So that's the percentage going from here to the left. 95.99%. We don't want that percent, do we? So you take it off the 100. .01. So that means you go to the lake, and if you caught a fish that's over 17 inches, you had a 4% chance of that happening. It's a pretty good sized fish, though. For Cumberland, yeah. Yeah, we went down to Alabama this summer, and that's a little one. Down in Alabama, down at Lake Enterville. So, yeah, for Cumberland, if you even catch them, I always get skunked. I get skunked a lot. I don't know. Maybe it's because I suck.
I caught one 2 years ago. It was 21 inches.
I think it's
But it ended up breaking the tip of the pole before I got completely in, so I lost the pole bringing him in.
Okay, so let's try weekly income of teachers in a school district. We're going to assume this is normally distributed. It didn't say it, but we're going to assume that. So number 19. So in the middle is 390. And then our standard dev is $45. Go up by 3, and then down by 3. Is that right? 435, 480, and 525. Okay. 3, what, 35? 45? 3, 260, 255. Take away 45 and add 45. Get your up and down. Everybody good with that? Everybody understand that part? What we're doing? That's all we're going to. Yeah, that's what we're doing the other day. It's the second time you're seeing it. Yeah. Yeah. Because we're seeing it again. This is why they say to always do stuff before you go to class. Because then the second time you see it, it just sinks in a little bit better. It's not because they're trying to be mean to you, right? That was the point of it. So, percent of teachers earning more than 425. 425 would be right here, behind 435, I guess. There's 425. And it says more than, right? more than. So actually the answer is going to be this part right here. But remember, our table doesn't work that way. So we're going to find the table value and then subtract, correct? So we're going to find our table. But to use the table, we got to have a z-score. So 425 minus 390. So that'd be what, 35? And then that's the number you're looking for minus the mean. And we're going to divide that by the standard dev, which was $45. So what's that number? Can you divide? 0.777777. So 0.7. We'll go ahead and do 78.
That's what I was actually going to ask. Is when we did like 15 last week, we didn't round up the repeater, and so the answer didn't match the paper. And then
Okay.
I realized when we got to this one that if you rounded up, it did.
Okay, yeah. Last time we did one, we didn't round correctly. So this time we're going to always try to round this to the nearest.
I was curious about that. Like, if we got the test, do we need to round?
Yeah, round it. Always try to round that thing. And that's the one thing about using the table versus anything else. It's not going to be as exact, but I mean, gosh, it's not that big of a deal, I guess. So 0.77 is our z-score. So we go over here to 0.7 row. Now remember this is 0.7. Okay, 0.7. So you go to the 0.7 row, and it's 8, right? It's the second number, second decimal. So 1, 2. Well, I'm just going to go ahead and follow it down here. So I'm going to draw this line over through that row, and then draw the 8 down, and the crosshairs will tell me what the number is. I like doing it that way better than counting and such. 78.23. So from here to the left is 78.23%. We don't want that part though, do we? We want the other part. We want the complement to it. So subtract that from 100. What do we get? Cool. So 21.77% of teachers make more than $425 a week.
I determined one I did that. I didn't.
Did you put the 78.23 in your calculator? Or 0.2? Okay, that's fine. That's fine. Just make sure you write out all your work and stuff there. Like whatever you type into your calculator, that's what I would type. If you're just going to write down this answer, 21.7, and you don't have any other work, you're putting all of your chips on that number right there. There, it's either right or wrong. Now, if you had, here's the other point I'm getting at. If you had just put this down, and no other work, I don't know how, I mean, if you had all this other work and you just left it at this, the 78.23, well, I can see, oh, you just forgot to take the other part. You even had this shaded. You knew that's what you wanted. I'm just going to say minus 0.1. Not even take anything off at all. I don't know. But if that's the only thing you got, I'm going to take off maybe like 0.5 because you didn't do the other half of the problem. Okay, so make sure you're showing your work. And really what I'm trying to do is get you prepared for your other classes. Because once you get into, I mean, they all want you to show your work. The only place where they don't want you to show your work is if you were starting to do like a dissertation on a doctor or something. I mean, that's the part where everyone kind of knows what they're doing, so you don't have to show your work that often. If you're trying to write scholarly articles and stuff like that. But most of y'all are far from that point. Eventually you'll get there. But okay, so number 20, I've run out of paper. I guess we'll have to do this here somewhere. Number 20 says a bank loan officer rates applicants for credit. Ratings are normally distributed with a mean of 200, standard dev of 50. An applicant is randomly selected. Find the percentage of applicants with a rating that's between 170 and 120. That question there is like that other one, sort of like those quarter question, where it's in between two numbers. So you're going to have to do some subtraction. So here's the answer. key page here. I'll tell you what I'm going to do. What's the standard deviation? I'm sorry, the mean? Okay. What's the numbers they're going to give us? 250 and what?
Oh, wait. I thought
You want to know
The-
the numbers?
The actual numbers that they're asking between the two numbers.
170 and 225.
Okay.
220.
So here's what I'm going to do. 220 and 170. And we've been saying above. We've been actually putting those numbers at the bottom and the top, right? None of them have been hitting exactly on standard deviations, and I'll let you on a hint. They won't, because I want you to find the z-scores. Okay. So if you want to not make it so many steps, all I want to do is find between those two numbers. So I'm just going to find z-scores for these. Okay. So remember, Taylor, how we said there's so many steps. Well, no. You don't particularly have to write out those standard deviations. You don't have to. It's good to know because that way you know where things are. Okay. And it's a good approximation. It's a good thing to do, but it's if you don't have to. So you can find the z-score for 220. And then you can find the z-score for 170. And your calculator is just going to say 0.4 and 0.6. But there's a 0 at the end of those. So I'm going to, let me step back and let you guys work on that. Make sure you get those numbers. Did you get those z-scores? Negative 0.6 and 0.1. Taylor, get those? Okay. So it's 0.6 and 0.4, right? So I'll do the positive one first. 0.40. 0.4 is the row, and then 0 is the second. So first column, 0.6554. So from here, I shouldn't have wrote that there. So from here over is 65.54%. We don't want the whole thing, right? We just want this middle part. That's what we want. So what we could do is find out what this little other piece is and subtract it off. So let's figure out what this other piece is with negative 0.6. So we go to the negative side. Look for our negative side here. It's 0.6. So I'll go to the negative 0.6 row. And the second decimal is a 0. So it's the very first guy here. 2743. 27.43%. So I don't want this other 27% in the 65. I don't want it. So I'm going to subtract the two away from each other. What do you tell her? Sounds good to me. So 38%, 38.11%. What was this about? If you randomly select someone that had a credit score between 170 and 220, you have a 38% chance of picking someone. The probability of picking someone between those two numbers is 38%. So what do you think? Better now? So?
This
let's check out one of these questions that says a lot. It has one graph and it says ask a lot of questions here on the textbook. Come on. Page 830. Page 830. Numbers 59 through 64. So number 59 through 64. We're going to do some. Assume that the speed of automobiles on the expressway during rush hour is normally distributed with a mean of 62, standard deviation of 5. And since there's going to be like 1, 2, 3, 4, 5, 6 questions on this one thing, I would go ahead and write in those standard deviations. Go up by 5 and down by 5. That's what I would try to do there. So, go ahead and draw your little chart there. Draw your curve. I'd draw this fairly large, since we're going to have. That's horrible. Oh well. 62 is the mean, and then we're going to go up by 5, down by 5. I can't draw on top of this book. So the book says that the average is 62, and the standard deviation. That's a horrible graph. I can't stand it. Okay. We'll try one more time. Standard deviation was 5. That's a little better. 62 is the mean. Go up by 3, down by 3. Standard deviations. So 67, 72, 77, and 57. Yeah, 57, and 52, and 47. Yep. Is that what you guys got for your little numbers? Okay. So the first question asks, what percent of cars are traveling faster than 62? You don't need a table for that, do you? Faster than 62? 62 is in the middle. 50-50. Half for faster, half for slower. So, 50%. The z-score for 62 is 0. So if you had to go to your table, you look under 0, 0. So if you go to your table and look at 0, 0, what's the number? 0, 0 is the very top corner. It's 50. So it tells you on your table. Oh wait. Okay. 60. What percent of cars are traveling between 58 and 66? So 58 is right here. 66 is right here. So I need to find z-scores and find my table values. So I'm going to come out here to the side. I'm going to come down here and do my work. And I'll just do it quietly, and maybe you can work out and see if it's the same. You need to find both of them, because what's going to happen is if I do the 66 z-score, it's going to tell me everything to the left. And I want it to stop right here at the 58. So I just want this little piece in the middle. So that's why I'm going to find both of them. Yeah, because I don't want to include both of them on there. Take them out. It's 57. So that shaded part that I did, if I shaded all of it versus the part that I just shaded here in the middle, that middle part represents 50% of the whole thing, 57.62. It's between those two numbers. Out of all the cars traveling down the road, 57% of them are between 58 and 66. Everybody get that? Let me get those numbers. I get all in one page here. 62 asks, what percent of cars are traveling faster than 70? Oh wait, 61, that's what I'm on. What percent of cars are traveling slower than 56? Well, 56 is not an exact standard deviation, right? So we'll just find a z-score. So, slower than 56 is what's asked. So 56 minus 62, that'd be 46. Negative 6 divided by 5, be 1.2. Negative 1.2. So negative 1.2 be 11.51. Now would I subtract 11.51, or is that's good as it is, isn't it? Because slower than is to the left, and that's what our tables tell us. Slower than. $62. What percent of cars are traveling faster than 70? Now, if I do faster than, there's going to be some subtraction involved here, right? Because faster is the above part. I want the table only tells me the left part. And what's the right? What's the number? That's 70 miles an hour. So that needs a z-score. 70 needs a z-score. So 70 minus 62 is 8. And 8 divided by 5 would be 1.6. Okay. So 1.6 is going to give me 9452. Now, you know that 94% of the people driving is not going 70 miles an hour. That's what the little table doesn't say. You don't want that. It says more than the question. You want this part, but that's not what the table tells you. You found the other half. So you better subtract that away from 100. And you get 5.48. So far, so good? We're going too fast? Going too slow? Take your silence as a yes and no at the same time. Jump down to number 64. If 200 cars are selected at random, how many will be traveling faster than 70? So 64 asks, if you did a sample of 200 cars, and what percent, how many cars are going faster than 70? Well, do you know what percent of cars are going faster than 70? Yeah, what percent are going faster than 70? 5.48. So why don't we take that percent of 200? That's what you do.
That's how this stuff relates to real life. Is if you predict the future with it, basically. So you figure out the normal distribution, and then you can figure out something about the future. So 5.8, you take 0.0548 times 200. What do you get? 10.96. 10.9. Right. So I'd round that up to the whole car. So it's 10.96. That's what you said, I think. And then I have to go and round that to 11 cars. So if you get a road that 200, if you had a police officer that was sitting in a road that got 200 cars passing in his shift, and you could expect him to ticket 11 cars. If he doesn't ticket 11 cars, he didn't meet his quota. Y'all heard of that before, right? Quotas. It's not just we need to make this. Well, that's what I've heard. The county needs this much money this month. And no, it's basically it would be like saying this is how many cars are probably speeding, and you need to be doing your job in catching speeders. That kind of idea. So that's how they can come up with these numbers. You think, well, how in the world do you know it's that number? Well, you go to statistics, and not every day it's going to be 11. Maybe some days it's 12 or 13. Maybe it's none. I mean, you never know. But over the long haul, over a month, it'll average out to about 11 cars a day. Over the long haul. So this is the critical thinking type question that I would ask you. Is we've done all of this, and then you have to use this. You got to make sure you understand this to do and critically think about how would I use it, how do I apply it, and this is how you would apply this. Is you can find the percentages using the normal curve, and then figure out maybe a real world situation where you would find out how many cars. So number 68 and 67 talk about cornflakes. It's the same idea. Number 67 says if a manufacturer produces 300,000 boxes of cornflakes, how many will contain less than 5.83 ounces of cornflakes? You ever open that bag of potato chips and you're like, oh man, what?
It's half air.
Yeah, it's half air. And like, there should be more in there. I got gypped. That's kind of the idea behind this. So you use the cornflakes. I assume the amount of cornflakes normally distributed within the 16 standard deviation of 0.1. Draw your little curve. You find your percentages for 15.83 in the case of number 67. You find that Z-score. You find the percentages. And take that percentage of the number, just like number 64. Okay. So what we're going to do, I think we've thoroughly covered normal curves. But what I would suggest you do is go back into chapter 13 on page 830 and hit up all these odd questions from number 45 through 67. And make sure you can do those odd questions there, because you don't have any. I don't think there's a problem sets for these anymore. Okay. So you just want to be working on these and making sure that you're getting the odd ones. And it sounds like a lot, but they're just odd ones. And we've already done 59 through 64, so it's not a whole lot there. I think we did the SAT scores too. I can't remember. That's what I would suggest you try to do, is go through there and do those odd ones. Then, if you have any other questions, we can answer them Wednesday. But I'm going to focus a lot on this logic as well. So you might want to go back and look at some of the logic stuff. Tell you said you had issues with it. Like on, so with me, I go home sometime tonight or tomorrow, try to knock out this normal curve stuff one more time, and then try to bring up this logic stuff and work on it some before class. That way, you know what to ask. If you don't know what you don't know, then you don't know. No one knows what you don't know. If you don't know, no one knows. Ask. So next Monday we're going to test for. So try to be wrapping up everything for this test review on Wednesday. Sound like a plan?
So on the test will be those. The problem that 16 and the problem set.